Hello, friends. We're back. I'm back. We're all back. We're back in ComfyUI. Well, not yet. We're back on YouTube. Hello. It's Purrs Creative Exploration. Hello. We're back. Last time we did custom motion Lauras, and I've been training a few more, and they've been really fun. But today I want to actually start tearing apart two of the workflows that we built this last time, subject masking and context smashing, which is the 6-color IPAdapter masks. The reason I want to get into this tonight is that a lot of AI animation that I see is awesome, but it's like every pixel on the screen is moving, right? Because it doesn't really differentiate between spaces in the scene. It just sort of just moves everything. Some stuff's less than others, but everything's pretty much always moving, which is kind of how reality is, but not always. And sometimes we want to control sort of where things are moving. This will make more sense as we get into the masking section of this, but all this is to say that this particular episode will probably be pretty dense. If you don't know what the hell I'm talking about, if you look in the description below, there are two videos. One is subject masking with ComfyUI, and the other is 6-color RGB mask, RGB CMY masks for Comfy as well. And those are the two big main workflows that I've got going on right now on Banadoko and stuff. And it occurred to me that like we release these workflows and then something new comes along and we just kind of jump onto the next shiny. Like for instance, tiled IPAdapter nodes came out, so we're going to jump on that shiny tonight while we're doing this other stuff. But I think it would be fun to go back to those two workflows, look at them, and see how they can work together and how we can use masking to elevate our game. Because generating videos is great, but it's really cool to be able to generate videos with more intention. It is argued that a lot of art comes from the intention, not necessarily the execution. So if you are just constantly executing and never intending, it's cool, but it's sometimes more powerful if we can actually inject our narrative in first, like we do with pretty much every other sort of art form. With AI, we come at this stuff backwards a lot. It's we're making stuff and then we're building a story or a narrative behind it. But it's interesting to be able to decide what you want to make a video about and then make that video and then have it do the things you want it to do. And I don't want to go in as far as saying that this is like Hollywood level creative direction and stuff like that. But I'm just talking about being able to use your own thoughts, ideas, concepts, movements, and stuff to make it more your own than just necessarily like a slot machine that just generates really cool videos for you to post online. So yeah, I'll talk about tiled IPAdapter a little bit today because it just came out. I just found out about it and I started playing with it, and it's really cool. We were using IPAdapters before to influence style and face and anything we wanted into each color on the mask. With tiled IPAdapters, we can actually use images that are outside the aspect of a square. And we can also have it look at it in chunks as opposed to looking at tiny tiles. As a result, you get better results from these tiled IPAdapters. In my testing so far, I've only been testing today, but I've gotten some incredible results with AnimateDiff and a few other things. So we're all just going to dive in together and just start mixing all this stuff up in a new workflow. And we'll start simple, then we'll add each thing, we'll add masking, and then we'll talk about what we want to mask and how and why and the different ways that you can mask things. Talk about static masks versus animated masks, what the strengths are, what the weaknesses are. Benefits and drawbacks to each one in the sense of like what they can do, what they can't do, what they do really well, and what they hinder. And other interesting ways to use All the stuff is in Comfy. Comfy is very vast, and we don't use a lot of the image composition stuff in it in general. So let's dig into that. So yeah, that's just a long preface to say we're going to go deep today, but we're going to start simple. We're going to start with an empty workflow. We're just going to start adding stuff, and hopefully along the line it'll make sense. And if you have any questions, please don't feel dumb. Throw them out in chat, and I'll try to talk about it as I get to it, because yeah, I might just blow past something that doesn't make sense to you. And if you know, if I can help, I can help. So just shout it out if it doesn't make sense. I'll talk about it. Okay. Let me show you what I'm talking about with this tiled IP adapter first. So I was doing a bunch of tests with just images. Just looking for some face images I have in here. All kinds of random stuff in here. There, let's go with me, Bob Ross. So the tiled IP adapters, in my understanding, just looks at it more clearly because it can tile it into smaller chunks. And I mean, Matteo might tell me I'm wrong. Hopefully he's here. He can explain it better than I can. But yeah, for all my testing so far, I've preferred the results from this one, from tiled IP adapter masks, the IP adapter masked tiles. To get this, just update your IP adapters node. Update your IP, update all your nodes. But yeah, here, there's a good example. So that's the input image on the left. The one in the center is using the tiled IP adapter, and the one on the right is not. That's just regular IP adapters. And I'm noticing quite a few things. This, you know, we got this light on the side here. Oh, my audio's chopping? One sec, guys. Is it still bad? That sucks. Hope it didn't blow the intro. Is it still bad? Let me know. Okay, yeah, so the center one is with the IP adapter tiled, and the one on the right is without. I'm noticing a lot of subject stuff. You see all the extra mountains. We got too many branches on the trees, too much hair, stuff like that. For whatever reason, this one just seems to get it. All right. I think it was my mic cable. Sorry, guys. If you need me to repeat the beginning, let me know. I don't know how bad the connection was. Okay, cool. All right. Blah, 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 blah. So, tiled IP adapters are cool. We're going to just plug them in today and see what they do. I got some really good results, like cranking the res, and using tiled IP adapters seems to fix a lot of the double subject nonsense I was getting with weird aspects. Let's dig in. All right, for this, I'll be using efficiency nodes and a bunch of other stuff. If you don't have them, if the nodes don't make any sense, just look in the top corner of every node that I add. Efficient loader. You'll see this little badge here is going to tell you the name of the custom node group that it comes from. So if I'm working on stuff, you see a node you don't recognize and you know what pack it's from whatever this says up here. Then you can go to your manager in Comfy and just say install custom nodes and type in the thing that was there. In this case, efficiency. And you can grab the efficiency nodes for ComfyUI, etc., etc. I'll try to mention them, but sometimes I forget. So just keep your eyes peeled. You'll see it up in the corner there. So this is the efficient loader. It just does a bunch of stuff in one node that we usually do with multiple nodes. And in which case we'll use an efficient K sampler as well. All right, everything just connects. That's why I like these nodes, because it's sort of, everything's just together. And then we'll just do a save image on the end. And okay. So this is simple. We're just doing a simple load and view. So let's just go Dream Shaper, no LoRa. Put an NSFW nude into the negative prompt because this is YouTube. And we'll say, you know, a person standing on a lifeboat in the middle of the ocean. And this should just make an image. Whee! I'm assuming there's a person standing in that lifeboat. Okay. So here's the first thing I noticed with the tiled IP adapter. If we add the regular IP adapter, apply IP adapter. So it goes through the model path. So you connect it to the model. So it goes, model goes through the IP adapter into the case sampler. And everything else we just connect. So we add an IP adapter model loader. We'll use IP adapter plus. We need a clip vision loader. Right here. That one will work. So for the original IP adapter node, we need to add a prepare image for clip vision. And that's going to center crop it down to 224 by 224. Hey, AP. All right, so let's load an image. Load image. Okay, so the IP adapter is pretty much going to fully take over the prompt. So instead of having a prompt, we're just going to add like 4K. And just let IP adapters do its thing. So right now, this is just regular old IP adapters. Everything's connected normally. And as you can see, it does a really good job. It takes our input image and tries its best to diffuse it into something new. And this is the very basic concept of what we're using behind our RGB mask system, right? This is the we're inferring a style into each section of the mask. So this is how we do it. We use IP adapters. So this is the original IP adapters, but then let's use the tiled one. It's IP adapter masked tiles. This name may change, but for right now, it's this one. Pop the image into there. Actually, we don't need this prepare image for clip vision because we're using the tiled one. So plug that right in, which is my understanding. And we'll just use the exact same loaders and stuff because it's, you know, it's whatever. And now, if I want to see these side by side, right? So I right now, this is actually the really cool thing we can run across right now. I'm in a situation right now where I want to test stuff side by side. I want to see what it does with, and I want to see what it does without the tiled tiled IP adapters model. So the easiest way to do that is just to set up a second K sampler. So we've got everything routed to both of these right now, but this model out is our sort of divergence point. So if we just make another one of these by copying it and pasting it and putting it below, plug the model from the second one into this, and then plug all the same stuff from the other one into this one. Basically, our only divergence point is this, which IP adapter node that it's using. And then we can very easily compare exactly what the one is doing versus the other, which is very important because like in AI, a lot of it's intuition. And if you're not truly testing A/B, you don't really know what it's doing. Just take that from someone who wasted a lot of time thinking they knew what things did, but they don't. Until you actually test them. Same thing here, copy and paste that, and we'll just use the same settings. And to ensure that you have the same seed on both of them, just right click on one of them and hit convert seed to input. We're going to do that on both of them. And that's going to turn this seed widget into an input. And then we're going to use a seed node for both of them. So we're going to add a seed node to the front called seed everywhere. And that's a UE nodes node. There's a bunch of different seed nodes. Use whatever seed node you like. Just type seed into the search. You probably already got one. So we'll go 42069. And control after generate is going to be fixed. So that makes sure that this seed stays the same on both of these runs. And we know it's using the same seed with two different IP adapters with all the same settings. So now, I forgot to plug the model in from the original. Okay, so hopefully this makes sense. Let's, so these are for both of them. This is for this one. This is for this one. This stuff goes here. Just trying to rearrange this so it kind of makes sense. All right. I know it's a messy thing of cables, and I don't have my linear cables on right now so that you can see where everything's going, because with linear cables, they get lost. So it's sometimes good to have these squiggly cables on when you're starting, and then do the linear stuff later when you don't need to know where everything goes. Okay. So we're basically just diverging here at the IP adapters. So we're testing one versus the other, and we're plopping both of them into a window, into their own save image. And I mean, you can go one further and rename them too, so that they actually, you can look at them later and know what they are. But for now, we're just doing this for tests, so you don't have to do that. So this is original IP adapters versus the tiled IP adapters. Here's where things get really interesting. If I increase the latent, like the size of the size of the generation from 512 by 512 to 1024 by 1024, I'm finding I'm getting much better results from the tiled IP adapter. Oh, not now. Hold on. I forgot to add we forgot to add one thing. When in SD15, if you're going above the sort of default resolution, it's a good idea to add a deep shrink node. Kohya Deep Shrink. So we're going to pop one of those into both of these after the IP adapters. Model in, model out. Okay, so it goes IP adapter into Deep Shrink, and then IP adapter into Deep Shrink. So now, if I'm right, these should be actual human people, or at least they should look like subjects correctly. Yeah. Does tiled work with vid to vid? It sure does, buddy. It sure does. We're gonna get there. Okay, here we go. Tiled versus untiled. We can try this with some other images. If you want to put these all side by side, in like converge everything together, there's a node called Image Concatenate. And you can just take your, let's do it the smart way. We have a width and height. We want to set that in several places. So we're going to change them into inputs, empty latent width, empty latent height. Turn them into inputs by right-clicking. Now they're inputs. We also want an image resize node. No, we don't. We want an image upscale node, or an upscale image node, rather. And we're going to do the same thing here, width and height. And we're going to tell the crop to be center. All right. We plug this, our default image, into this. And now we need to declare our width and height. We're going to add an integer pair. This is in the Serge SDXL group. You don't need to use an integer pair. You don't need to install this node group. If you just want to use two different integers, that's fine too. Just double click, type in integer, and find an integer node you like. It's all good. I just use this one because I can remember it's the resolution because it's 2. So we're going to set this to 1024 by 1024, and this will be our width and height, our resolution. So that'll get plugged into our empty latent width and height, and also our upscale image. All right, so that's our base resolution for the project. That's our seed. We're starting to get all of our nodes into modular places so that every time you need to set something more than once, it's at the beginning. Easy to use, easy to see. So here's our upscaled image. So this is going to resize our image to the size of our thing. We need this when we're about to put these three images together, because these three images need to be the same size. So let's take our upscaled image and plug it into image 1. We'll take the first image, plug it into image 2. So these going to put these images side by side. It's concatenate on the right. Add another concatenate node, plug this image into 1, and then we're going to grab that third image and put it here. So this one, we'll take the first 2 images and stick the third one beside them. And then we can look at that image by saving it and calling it the grid or whatever. And now when we save it, this should just automatically save us a little 3-piece comparison grid here that we can look at very quickly. Yeah, bingo bango. And then, yeah, then you can just start changing the images, whatever. Ryan Gosling, Winona Ryder, dancers. Hey, melting. Let's try, yeah, let's try these like angelic dancers, see what they do. There's also another IPAdapters that came out recently that just does composition, not style, which is really cool. I wonder if you could use, I guess you could use that in conjunction with this one. Interesting. Yep. It definitely stable diffusioned it up a bit. But yeah, I think the detail is better on this one. Pretty cool. Pretty cool, pretty cool, pretty cool. So let's use this in animation. How do the mushrooms look? I don't know which one's better now. I mean, this one's pretty cool. I don't love the detail underneath, though. I like it. I think I like that better. But this is way better. Cool. All right, let's let's animate. So yeah, you guys saw what I did there, right? 2 image concatenate nodes and then stick them together, make a grid, do your thing. You can also add text. You just grab the width from the other thing and do that. I've built text things on stream before. I'm not going to do it now. It's extremely meticulous and boring. But you could add text labels to the top of these as well, pretty easily. It's grunt work once you understand how. Kill that. Let's kill the... Oh, that's interesting. I had them backwards. I think I was preferring the original, so that's interesting. One sec. So this is our... This is why we need text labels. Maybe I have the tiled one set up wrong. Let me try my old settings, just double check here. Model comes in from here. Kohya out to you, yeah. And IPAdapter, flip vision, image from the upscaler. Bilinear, I think. Yeah, that makes sense. All the double stuff here. This is fine. Yeah. So how's Purr's Barbie look? Let's see. Hey, Hayden. So, who do we like better? I think this one's better. This one's got more stuff going on. This one fits better into the statue. Thanks, yeah. I'm trying something new. I'll have to do Barbie Halloween stream. Yeah. Just like the detail. Like there's like almost too much detail or something in the original, but yeah. This is cool. So let's get rid of the testers. Blom 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 blom, and we don't need this stuff. Or this. All right. Kohya Deep Shrink. IPAdapter. That's the model. That's the image. We're just making stuff now. All right, cool. I know this is ugly. We don't need this anymore. We can smallify that. Smallifulate it. Okay, cool. And we can smallifulate this too. All right. Just trying to clean this up so you guys can see what the hell we're doing here. Yeah, I think that's the way to go right there. Boop. And we'll do one of these. Okay, so we need to add AnimateDiff to the mix. We have IPAdapters, so we're going to put the IPAdapters in first. And then AnimateDiff. Let's try that. IPAdapter, then AnimateDiff. It looks like crap. We'll go the other way around. So we want the AnimateDiff legacy loader for now, because we're just doing AnimateLCM nonsense. Okay. Our animation is large. It's 1024 by 1024, but because of Deep Shrink, we can just do it. So that's pretty cool. Let's plug the model through. IPAdapter, AnimateDiff, K-sampler. If this looks weird, I'll try wrapping it the other way around. I always forget which way is the right way. But yeah, I usually go IPAdapter first, I think. Having a brain fart right now, people. See, I've built thousands of these workflows and it can still happen. You just forget stuff. 1614, blah, 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 blah. All right, cool. Sample settings. We're going to go with repeated context. All right. And I'm going to add a motion LoRa. We're going to use Jeru's Shatter LoRa. As you can see, I've been training them. Let's go. Or maybe we'll do, yeah, let's use, okay, I'll start with Shatter because I know what it looks like. Yeah. All right. 0.5, 1.15. Here's the AnimateDiff settings if you want them. Here, I'll just move that stuff out so you can read it. You guys can screenshot that if you want. And that's basically the settings, that beta schedule, actually, we're going to change that to LCM average or LCM greater than square root linear. Either one. Motion scale 1.15 to start. Strength at 0.5 for whatever motion lower you pop in. Increase either, see what happens. Context length 16.14. 16.13 is fine as well. 5. I wouldn't go below 3. I wouldn't go above 7. You can do what you want, but that's just basically how much time it takes to go slide between each context window as the animation goes through. The different animate, what are the different noise types too? That's a great question. These are just different ways that it pushes the pixels around in the motion engine. So they just result in different motion, and sometimes it just results in noise on your animation. So repeated context seems to work really good with AnimateLCM. Empty works good too. If this looks like it sucks, I'm going to switch to empty. But yeah, just try them. Just try stuff. Make sure you're actually trying it with all the same settings though. That's all. So that you know what they're doing. Same seed, same everything. Especially with motion lore, or with like the motion models and stuff, like AnimateDiff, you really have no idea what it's doing from one seed to the next. It can be wildly different. Okay, so let's try to differentiate these a bit. You guys will be yellow, and y'all be cyan, except the image loader is blue. Not green, blue. Alright, these will be green because they are settings, and yeah. Cool, and you'll be purple actually, because you're part of the diffusion chain. Alright, we don't use a save image with animations, we use a video combine. Alright, set the frame rate to 24 frames per second. MP4. We'll set the CRF to about 15, 14. We will save it, and I'm going to use, I'm going to change this to an input. I'm using this node called file name prefix. File name prefix by Mikey nodes. Yeah. Actually, I'm going to use the other one. File name prefix date directory first is the one I'm going to use. So basically what this does is it makes a date directory for today's date for the stuff you're making. So if you use these all the time, the stuff will fold into folders of daily, sort of, and sort them with daily stuff. So yeah, I just recommend it. So we're testing IPAdapter tile stuff, and the custom text is 24 FPS because this is just the regular animation. All right. So that's going to make a file folder with today's date, and then inside that it'll make an IPAdapter tile folder, and inside that it'll save this as 24 FPS 01.mp4 or whatever. So yeah, I like these file name prefix nodes. They're really cool because then when you have everything set up and you want to make new ones, you just copy it, plug it in, and change the info, and then you can like keep everything separate so you don't go totally nuts. Like my output folder, when I don't do this, is like it sucks. It sucks. All right. So yeah, it's just a good habit to get into. But once it's set up, you can just you just click on these nodes on the little dot, and they'll minimize. So you can then just tuck them up against the other nodes if you don't want to be looking at it all the time. All right. One more thing, our batch size. We're going to turn that into an input because later that's going to be determined by the length of our input video. But for now, we're just going to set it. So we'll set up an integer. I'll use the Chris Tools primitive integer because I like to use 3 different node packs if I can to do integers. Just makes sense to me. That's sarcasm, by the way. But yes, it is does make me laugh a little bit. This one's going to be our resolution. N. And this will be our seed. And this will plug into batch size. Later it will plug into the frame count, but for now, batch size. And we're going to set that to 24. We're going to make a 24 frame animation so we can watch it jump a context window and see what it do. All right, so this is a dead simple AnimateDiff workflow with tiled IPAdapter. The rules with tiled IPAdapter we should talk about first is so it's mostly for when things are the wrong aspect. So if my input image is wide or tall, I need to select the short side so that it knows how to tile it. The short side tiles parameter defines the number of tiles to use for the shorter side of the reference image. Number of tiles for the other side are calculated automatically. So if the image is in landscape or portrait mode, that generally means that only 2 tiles are created. If the image is a square, the value must be at least 2 for the node to have any meaningful effect. If the aspect ratio of the reference image and the latent are very different, the image will almost certainly be stretched or squashed. The tile weight is very important anytime the short side tile's value is greater than 1. The default value of 0.6 should be good for most scenarios, but you need to lower it a little for SDXL. The parameter has no effect if the short side tiles is equal to 1. All right, and the weight should be at about 0.7, which is what mine's at now. Okay. So it says should be set to 2, and I believe mine is set to 2. Yeah. All right, let's hit it. So this should just make an animation of this YOLO, but at 1024 by 1024, and hopefully it'll maintain some semblance of not double subjecting and all that stuff. Let's find out. Oh, no, we're not going to find out yet, because I didn't set up the LCM stuff. So because we're using LCM, we need to first, I think I didn't even set my checkpoint. Yeah, wrong checkpoint. Okay, select an LCM checkpoint. They're all available on Civitai. Search for LCM checkpoints. Photon's popular. I like Realism by Stable Yogi. There's a whole bunch of new ones I haven't played with yet, like Dreamcrafter and Comic Craft, and all this stuff we can dig in. Tonight I'm just going to use Realism by Stable Yogi. I like it. It's consistent. It's good. We are also going to add a LoRa stacker. We're going to turn that LoRa down to 1, and we're going to make it a AnimateLCM LoRa at 0.05. I know that seems really low. It is. Actually, we're going to set it at 0 to start. I'm just going to have it connected, but we're going to turn it off. So this is our AnimateLCM LoRa. We might not need it. I'll explain that in a bit, if I can. Okay. So that means I think that's literally everything to set up for the run. What is happening? Did I maybe... Oh, you know what? I bet this Kohya Deep Shrink needs to go after AnimateDiff. Oh, I still didn't set up the stuff. I set up the LCM stuff, but not the... So yeah, it also needs to be 11 steps, CFG of 2 or 1. We're going to use the LCM K-sampler, and we have to set it to SGM uniform. Okay. Those are the settings for AnimateLCM to start. You can play with them, change them, do what you want. But this will get you something decent right out of the gate. And I'm actually going to move this Kohya Deep Shrink out of So we're going to go efficient loader, IPAdapter, AnimateDiff. Then we're going to deep shrink into the case sampler and see how that goes. Purple. Okay, let's try that. I think this is how I had it set up. All right, edit group title, settings, checkpoint. This one is our IPAdapters. This is our AnimateDiff. This is our, whoa, excuse me, diffusion. First run. This is our output. Group green. Yellow. Purple and blue. All right, cool. So that's the whole pipeline for essentially what we're doing here. We're just taking an image and turning it into AnimateDiff animation, using different motion LoRa's to do different types of motion, all that kind of thing. But the cool thing is we're doing it at 1024 by 1024, which is normally looks like crap. So yeah, this is interesting. So after this, I'll start talking about how we can use masks to control different parts of the image. I'll probably get much faster results when I switch back to the regular native AnimateLCM res, but when I do, I may have to disable that deep shrink. I'm not really sure what that's going to do. When it's not above the base resolution, I don't know. Might be some noise in this one. I'm not sure. Hard to say. It's very chill. Kind of gross. This is definitely one thing I noticed, is it was very, very stationary, which is actually cool. Normally the animations are very like, and I don't know if that's because of the tiled IPAdapter or not. So let's try one where I just feed this image into the VAE and we turn off the IPAdapters and see what that does. Because now I'm curious how much effect the IPAdapter is having on it staying in that exact pose. So in order to do that, we don't actually use an empty latent image, so we don't use the stuff from here. We're going to take our upscaled image, which is at our resolution for the thing, and we're going to feed that into the VAE. So we're going to add a VAE encode node. This will come in handy later when we try inpainting. So let's take our image, and not here, our upscaled image, plug it into here. We can minimize that and hide it again. And now we need our VAE from the original efficient loader. That goes into our latent image. Okay, so now we're encoding this image into the VAE. But we need a batch of 24, and this is only doing it once. So we need to repeat this batch. So we need to add a node called repeat latent batch. Okay, then plug the latent back in. And you guessed it, we're going to turn the amount into an input and plug in our frame count. All right, so now it's going to make 24 frames. So we don't have to do anything here. This is fine. We can actually do something else really cool, which is we can take this latent, and we can make a switch. Okay, so let's make a switch node, latent switch, which is a Chris Tools node. So on true, we're going to take the image out of here and use it as the thing. On false, we're going to use noise. We're going to use the empty latent. So our latent out from the image, and then our latent, or sorry, the repeated image. And then the latent out from our efficient loader. Right? And then we're going to pop that into our latent image. So now this switch here is actually going to switch between whether we're using the images on the VAE encoder or we're just using this regular efficient loader. So you can call this the VAE encode switch. And I'll just pop that up here. And I usually make my switches black just so they stand out. And purple, and this is red. All right, so we're encoding our VAE. Repeating the batch, and then here we're deciding whether we want it to be the input image or that. So we're going to use the input image, and I'm going to actually turn IPAdapters off by setting the weight to 0. So this will just be feeding the original image in for every frame, and we'll see what we get. Might be nonsense. Actually, I should probably make this smaller. I think I'm a pretty lady, apparently. Yeah, I thought maybe this would happen. Cancel that. We'll turn you back on. Let's see what happens if we just switch the resolution to 576 by 320. We'll just slide it right back down to... Oh, you know what? I should have gone 320 by 576. And one other thing we can do is we can preview what our upscale image looks like too. So you can see what your crop, basically see what the crop is going to look like. So next run, that'll do that here. It'll show us what our upscaled image is. That's much faster. Gross. Gross. Let's turn off our motion more, huh? So yeah, that's what the crop looks like. And we're feeding the images in. Creepy. And let's bypass that. Yeah. Not bad. So let's try 512 by 896. So this is without Deep Shrink, going twice as big as AnimateLCM, but using the tiling and everything. So if it's a lot of wiggles, we might be able to turn Deep Shrink on and fix that. We'll see. Many, many wiggles. Who would have thought it takes twice as long to do a twice the size res or more? That looks pretty good without Deep Shrink. Cool. Okay, let's stick there for now. So we're going to use this method to start making some masks and stuff. I'm actually going to make the masks in Blender because making the masks in Comfy is possible, but with changing values and stuff, it's a lot of math. It's a lot of like pre-thinking and pre-doing. And today we're just going to be messing around with you know, what's possible. So I just want to be able to kind of generate the masks really quickly. Just use them, resize them, do all that stuff, crop them, whatever. So what am I talking about masks? Well, if you've seen my context smashing, the 6-color thing, or you've seen the subject masking workflow, you know how powerful masks can be because we can mask things out and we can move the masks around. We can slide context by moving masks around. So with the context smashing, we're literally using animated masks and just putting things together. With the subject masking, we're masking out the person, the background, and the ground. And we're putting things into that. But we can take it a step further by masking out the person, the bottom, the background, whatever. And maybe we use an animated mask for the background and leave the subject not animated. That's one thing that's possible. You can also mask things, mask IPAdapter attention to certain places and use multiple images to generate one animation where it's not moving, but the actual masks are static. So that's the first thing I wanted to talk about tonight, was like using static masks with IPAdapters. And then after that, we're going to try doing a subject on top of those static masks, and then we'll try and animate the mask below and have a subject on top. Let's see what we get. I'm curious to push the mask thing a little deeper. So yeah, let's see what we can do. Here's our output. Here's our diffusion. Here's our AnimateDiff stuff, IPAdapters. So let's move all this stuff over. Doobie doop doop doop. So we're going to need at least 2 IPAdapters for 2 different attention masks. So I think copy these, delete these. Yes. Model goes through, and it is literally that simple. We have a second IPAdapter now. The mask tiles IPAdapter, however, does not have an attention mask. Okay, that makes sense. So we're going to just use the regular ones. Model, model, model. Okay. Scale image for both of these. We'll go in here. Sure. Wait. No, we want to prepare image for clip vision for these ones. We don't need these upscales. You guys are fine. You aren't. What are you connected to? Right. Got to rebuild that upscale image thing I just deleted. Okay. Yeah, convert width and height. Plug them in. All right, and then our image from the first. Oh no, we're not using this anymore because we're gonna do different masks. Sorry, I got ahead of myself here. Just try to clean this right up. Dead simple, dead simple, dead simple. Okay. These will work for both. So we're just stacking one IP adapter after another, and we're going to use the two different attention masks to apply things to two different areas. It's like we were doing with the other stuff. So let's get a prepare image for clip vision. We'll say center. The load image goes in. We need another one of these. The side, this goes in here. This goes in here. Okay. I know it doesn't make a lot of sense, but we're loading the image, preparing it for clip vision, slamming it in. The image, prepare for clip vision, and put it in. Okay. Try and clean this up. Okay. So in this case, all I need is a mask. I'm actually going to generate it because we're just using two. So create shape. So when you want to do stuff like creating a shape and you have a workflow that's already doing stuff, just grab that node, Control C, hit it, open a new tab, go to 127.001, whatever your comfy thing is, hit clear, and just paste that node in. And now you can work with this node in this window without disturbing the other one and having to stop it every time you run something. Because right now we need to figure out what we can do with this node to make something cool. So we need to make a mask, and that mask needs to be the size of our animation. So like with this node, for instance, we're just going to switch the frame width and height to an input, and we're going to use that same integer pair from our other node because we're just going to plug it in after. This one, the resolution. Grab that, drop it in here, plug it in. Nice. So we have our resolution. We're going to have a look at our mask preview. And we're going to have a look at the inverted mask. Both. Okay. So this node will create a circle. 256 pixels in, 256 pixels down. The shape width is 128 and the height is 128. So what's a cool thing we can do? Start changing numbers and hitting buttons. Now we have a giant ellipse. It's 1024. Okay, and then we move it down maybe 512 on the Y, so it's dead center. That's not dead center. Oh, wait, what's half of 896? 448. Hey! All right, what happens when we grow it? Does it get blurry? No, it doesn't do anything. Cool. Okay, the width I'm going to set to 256. There we go. So this is a mask. This is a shape mask. We can use this mask to apply two different IPAdapter attentions to the black part and the white part. So let's do that. Grab this and this. Actually, we only need this. We know what it does, so we can just grab it. And we can say... delete this one. Put the new one in. Right? We take our frame width and height from here. mask goes into the first one. The inverted mask goes into the second one. So we can preview those. Let's add a mask preview. Same deal here with the inverted. Okay. That green. Okay, so we're making a mask and we're using mask to do two different images. So let's go through here. Where else? I just need, yeah, background. Maybe person. There we go. So hopefully it should put me in the middle and it should put the stuff on the outside. Hopefully. Oh, no, it won't because I didn't plug anything to the latent image because I killed that other node and didn't do anything about it. So we take this latent image from here, from our empty, blah, 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 hit it. So if I'm right, it should put me in this black part and the other stuff on the outside, which is actually really cool in a static image. Like an animation, you're actually setting up static boundaries inside of an animation. Okay, it's making nonsense. So I'm two-headed. That's probably because the deep shrink is off. So let's turn that back on. It's kind of working. So one thing I noticed that works really well with IPAdapters is switching this to channel penalty and just cranking the ever-loving crap out of it to 1.5. So let's try that. I mean, this is doing what I asked for. It's making this person in this background. But I want these edges to be like hard. Look at that weirdo. It's pretty amazing, though. I think it looks really good. So now that I've changed this to channel penalty and the weight 1.5, let's see if we can get these hard lines to happen. I don't know what it's doing. This is cool. Render. 11 steps is wild. So fast. Yeah, see, now we're getting those hard lines. You can see the context shift between the trees in this image and yeah. So if I was to yeah, maybe something like that. Yeah, let's try like a mall inside of this crazy place. Hey, Hugh. I don't know what it's making, but it's pretty interesting. I think it's making ladies, though. It's supposed to be making a mall. And whatever this is. Not sure what it's making. Oh, yeah, we're good. We're fine. Actually, that's really neat. So yeah, you ever see those hard lines like that in animations? I don't think so. Yeah, this is cool. So let's try changing this mask a bit. Let's just go back to 256 by 256 so we can just get a circle in the center. Let's grow it a bit. That make it bigger? No, it doesn't. Doesn't make it any bigger at all. Let's do. Oh, it just occurred to me something else. Location X and Y. Width and height. Let's go 448 by 448. How that? That's pretty big. All right, let's make that. Copy that. So one thing I'm going to do now also is I'm going to delete this, paste this. We're also going to change the frames to an input. And we're going to take the frame count in as well. I don't know if it will matter, but we're going to do it anyway so that it goes through the whole thing. Then I'm going to say unfold batch. Yeah, hopefully it doesn't actually matter, but we'll see. And we're going to mask to image. And then both of these are just going to get a little video combined because it's an animation. And then when we make these, we just make them MP4, but we turn the save output off so that you get the preview, but you don't actually waste the hard drive space on the preview because you don't need to keep it. Okay. Hit it. Oh, I get it. That's what grow does. Neat. So grow is an animation. That's pretty sick. Normally I make these in Blender, but this is kind of cool. So what if we grow by 10, or even grow by 20? Nah, that's probably too much. 10. We start at like 320. Will it just... I think so. Oh, interesting. Okay, let's just make goo. Why? Oh, because the masks aren't connected. I have a brain, I assure you. It does things occasionally. Okay, let's try growing it even faster. 40. From like, I don't know. Yeah, 128 by 128. So this should go from small to pretty big. Right? Hey. Cool. There we go. That's pretty sick. So as you can see, IPAdapters is extremely powerful. So this is just basically what we were doing the other day with the 6-color IP masks and the thing. I just I've never done it animation style thing quite in Comfy before. It's pretty cool. If you figured out exactly how long it took, you could make an animation that's exactly as long as your yeah. So if we were to go frames, actually we don't really need to make it an input. Let's say our animation is 48 frames long. We're going to start in the center. We're going to grow at a rate of 20, and the width and height will be like 1 and 1. That should go from like all one to another one. So that'd be like a transition. Shape circle. So then we can test this by just having a look at the mask to image. And then doing another video combine here. Same deal, 24 frames, MP4. Don't save. So this would be a 48 frame. 8. Oh, it has to start at 8. Okay. So you can't start from 0. That's too bad. Well, that almost. So it'd be like 22. 24. Yeah. Like the circle. So let's do that. 48 frames. Was it 256 by 448? 2488. 24. Shape width 8. Shape height 8. So this should literally go from one context to the other. All right, while this goes, I'm going to pop Blender open and pull up a static mask, and we're going to try some stuff. There's a speed run on how to make these on my last or on the 6-color mask thing below. There's a whole speed run on how to do this. I'm just gonna do it real fast because yeah, I've already done this on on stream 1,000 times. Do, do, do. Red, green, blue. Red, green, blue. Red, green, blue. Oh, I see. Generated. Yeah, red, green, blue. Very good. .311? Yeah. Okay. So I know I just speed run that with silently. What I did was I made a wave shader. I just will continue making RGBs for life. But then I just set it so that you can see all three of them. So that's a dead simple sort of red, green, blue mask, which we can then use to separate three different places on the screen instead of just the two. Well, that's cool. Yeah, kaboom. Very cool. Yeah, remember that. That shape mask has a grow function. Very cool. All right, we're going to delete this stuff because we don't need it anymore. We got our own masks now. This is a tall, so let's go. Let's change it from an X wave texture to a Y wave texture, and I want to actually spin it around so that it's red, green, blue. 180 degrees on the Z-axis. All right, red, green, blue. So that's three different things. I am going to very quickly set up a camera. We're going to say... And that should crop center when I... Yeah. F12, save. Temp. RGB. Y. Wave. Okay. You can make this image however you like. You can make it in MS Paint if you want. Doesn't matter as long as it's red, green, and blue. All right. Let's try making one more IP adapter. Don't need this. Do need this. And this. Yep. Okay. Image comes from there, which comes from here. Now we need to open our image, which is the one we just made. All right. So we want to mask out these three areas. It's actually really easy to do this. Color to mask. Okay. Red is 25500. Green is 02550. And blue is 00255. So these are our three masks. They go into each IP adapter respectively. Okay. Model, and then model comes through. Model. Try to get something else. So this should, hold on. I forgot to do one thing. We forgot to upscale our image to make it the right, and I say we, but I mean me. I forgot to upscale the image. This way we can ensure that the mask fits the aspect ratio of the thing we're trying to create. So we can see it here. So now if I did this right, the mask, yeah. So the red part should be the mall, the green part should be the canyons, and the blue part at the bottom should be the waves. So hopefully this works. You see these hard compositional breaks. So we can use these now to set up different compositions in our images when we're generating the animations. The cool part is what's going to happen, what you're going to notice is the AI cares about the lines, it cares about the style between the lines, but the overall animation, it actually flows over the lines. It's this really cool sort of free side effect that we get from AI animation, where it doesn't have traditional problems like, oh, this is a line here, I can't cross it. It's, oh, this line is part of the composition, so we'll just use it. So you'll see, like, sometimes it looks like it's all connected to the same scene, even though these lines they're pretty hard, but they're not absolutely hard. So now we can have a purple ocean with these spires in the mountains inside a mall, you know? Just a cool way to make interesting compositions in your animations and whatever. And then, as with any of these things, this you could just add like a image rotate. And if you want to just rotate it 90 degrees. This one sucks because it'll be like a lot of green in the middle and a little bit on either side, but you get the point. You can move your masks around and do stuff with them before you even, go back to your thing to make a new mask. You can probably make one of your changes in Comfy. I'm going to kill this. I'm actually going to reduce the time to 24 frames. Yeah. And then we're going to go in and we're going to make a different kind of mask. Wish you could get a little more granular with thing here. That should be cool. Yeah, let's try that. Ooh, actually, We can visualize, because this is the preview animation thing, we can actually visualize what it's going to look like. Yeah. So now I can figure out, I want to get as much of that blue as I can get. And maybe move it over a bit. Oh, that maybe. Yeah, let's try that. We did animation masks in the video below. That was last time. Today we're doing static masks, and then we're gonna do some animated stuff, as well as some other stuff. Yeah, we'll get there. All right, let's try this. Oh, see, that's cool. You're just breaking up against the sides. But yeah, we just literally did an animation mask about like 10 minutes ago as well. Oh, interesting. What did I break? It zoomed in on the center really hard. We can just go straight in on this one, I think. Oh, because it rotated. Right. Cool. Those curves really help merge the worlds together. Interesting. I want to try something with that curve, actually. I'm going to foray into animated masks right now real quick because I want to try something. So I'm going to make a 90 frame animation that loops the context length of one phase offset. Like that. So over the course of 90 frames, it'll loop perfectly. I'm going to save it as an FFmpeg video with perceptually lossless output quality. MP4. Yes, render. Oh, it's still large. Well, whatever. It'll be fine. Okay, and then let's have a look at it. We're not going to load an image anymore. We're going to load a video. That video. Okay, and we're going to have to visualize these masks so you can see what the hell's going on here. Need a video combine. MP4 24. I need 3 of those. Yeah. Okay. We got our video combines. They are going to show us what the masks look like. Okay. Okay, now we can see what they do. So we're going to make the animation 90 frames. To actually, no, what we're going to do is take the frame count from here. No, we're not going to do that either. I'm going to set the frame load cap to input. I'm going to use our thing to do that. And I know this is 90 frames, and I'm going to run it at 1 time speed. So let's go 90 frames. So if I did this right, should load the video, resize it properly, and we'll get 3 masks. So this is what the IPAdapters is seeing when it's supposed to put each context through on the animation, right? So it should morph between these 3 subjects over the course of the animation and loop. Can this be combined with Lightning? Yes, but IPAdapter and Lightning don't actually get along very well. So this particular workflow, not so much. I tried a lot of stuff last night. Could not get anything good out of it, but it's not to say someone won't figure it out tomorrow, so who knows. Or maybe they figured it out while I was here. It's possible. This space moves pretty quick. I was actually going to stream about Lightning today, but I just didn't get anything worth streaming about. Faster is not always better if the result is subpar. I like these little rocks. They're like mini, or they're like RVs. Yeah, I saw that right before I went on today. Open Zora was released. It looks cool. Looks very cool. To 2 seconds of generation is cool. All right, here we go. And you can upscale these too. You don't have to just do this the first run. That's cool. There they go. So now we're shifting context like the other one. Pretty cool. Cool. That came out great. And that's just using those 3 masks. So we have these 3 masks, right? We have stuff happening in the background, but what if we want to have a dancer in front of all of this doing something cool, but we still want to have this stuff happening in the background? How would we do that? Well, let's just do it. All right. This is going to be a bit of a haul, but we'll do it. Trying to think of whether we should do it. Yeah, let's do it in a new tab. All right. So we're going to keep that. Okay. All right. We're going to load a video. I'm going to go to my creative exploration folder and grab one of my input videos. Let's use Centimeter. He's a great dancer. All right. We want to turn this into a mask. So we're going to use robust video masking. Matting. Robust video matting. Part of the video matting suite. I'm going to leave everything alone the way it is, because all we really want is this this mask. All right. Let's look at the mask. Okay. We're taking our video. We're upscaling it to the width and height of our project. We're going to generate a video mask and we're going to look at it. This should pull the subject out of the background. I did not mean to do the entire video. Cancel. We are also just going to do the first 48 frames because we don't need to do the whole video. Hopefully this is not a super long video. Hopefully I didn't just kill... I think I might have. Yeah. We'll be back after these technical difficulties. The way Comfy deals with video is incredibly annoying. You know, I used to have a crash counter on my old AI streams, so we're doing pretty good now. Doesn't happen very often anymore. And this one was fully user error. I tried to load way too many frames into the buffer at once. Comfy has a very odd relationship with large videos and many frames, so what happened was I tried to load the whole video into memory and it oh great, glad it sounds good. All right, hopefully we're back. Oh. All right, cool. So we're just going to load the first 48 frames into the robust video matter. And it will generate the person on the background and a mask. So now we can use this mask to overlay on top of our other masks, right? And then pull it all out of that final overlay and have the 3 masks in the background and the 4th mask on top. Maybe we just do 2 masks in the front. No, let's do 3. Screw it. Okay, so what else do we need? We need to take this mask and combine it with the other ones. So I may have to work this one out for a little bit mentally. Sorry, I keep yawning. Let's load the other mask. Frank, I don't see the mask in my IP adapter. Which node, bud? Is it the apply IP adapters node? Because it doesn't exist in the tiled one. Okay, so we want to have stuff behind this guy, but we also want him on top. So how do I apply this mask to an image? We want to put this on top. This is where my brain always falls apart, but we can figure it out. Okay, let's load a video. We're going to load up this mask, which is 90 frames. So we're going to set this to 90 as well. That way everybody's 90 frames and everything's cool. All right, and we're going to do the same one of these, upscale. All right. Right, width and height comes from this node. Okay, so make a little playground here to figure out how to mask this stuff. So this should be the background, and we want to put this on top of this. So how do I make this yellow and then slip it on top of here? Let's take this image and multiply it. Oops, image blend. All one word. So we're going to multiply it. Multiply the image by image blank. Okay, image blank, I'm going to make red and green, but no blue. And its width and height, that's right, come from our global width and height. So if I'm right, it should make this dude yellow. Hey, he's yellow. So we want to put yellow on here. Okay. How do we do that? Probably another image blend. Maybe set to screen. Then we take this output and this output. I'm just freestyling here. So we just want to get yellow on top. Oh, whoa, oh, okay. So we got a slight problem here. We'll try all the different modes. Maybe it's just a question of getting the right mode. Not that. Okay, so I think what we need to do is image blend by mask, I think. And then it's image B, image A, no, image A, image A comes from the resize. This B, and then the mask is this? No. Is it the mask? Oh, you don't take a mask. Oh, you mad? Why are you mad? It should be the same size. Oh, I know. There's only one of these, I think. I might be dumb. Done this 1,000 times. It's something about adding an image with a mask or... Apply mask to image. That's it, I think. So our image is... No, that ain't it. Before I screw around anymore, I'm just going to pull up my old workflow and have a look. Because I already solved this problem in the past, and there's no point in wasting time. Image Composite Mask. Okay. There we go. All right. So if I remember, you're the source, you're the destination. Yeah. Okay, you're the source, you're the destination. And the mask is the mask. And you're not plugged in anything. Hey! Okay. We did it. Zoom in on this so you guys can have a look and see how it all works. But yeah, essentially we are loading an input video, masking out the subject, and then putting the subject in front of an animated mask. So we don't need to build this all into the other workflow. You can actually just make this mask making workflow and then use it here. Just like load the mask and get to work. It's probably easier this way than having to like make the mask in this project. So I would definitely keep them separated. So let's just save this and load it. Now that I think about it, no, it makes more sense to build it in the project because we're going to need to do some ControlNet nonsense. So, all right. Let's rebuild this in the project. We don't need all these outputs, though. We only need these nodes, and we just need to remember where all this stuff goes. So, this, and this. That's literally all we need. We can plug it into all of our other stuff. Okay. So let's do it up here. Load video. resize, put into video, make the mask, feed the mask out, make it yellow, spit it all back out. If I add a video combined to this, 24, MP4, right? And then this mask and this stuff goes into one of these. Okay, first things first, let's see what this does. Nothing. Blank, you need a width and height. I don't know how far this thing gets. Oh, I did it again. Loaded the video of all the frames. Terrible. Okay, well, let's restart. So I'm gonna grab a drink, stretch your legs, get up, move your body, or don't. I don't care. I'm not your mom. I'll be right back. Enjoy. All right. Hopefully we're back alive. Let's try. Dum. Okay, load video into our upscaler into the robust video matting. Robust video matting is going to generate our mask. With our mask, we're going to blend it with the yellow. We're going to then composite that yellow mask into this image. We're going to see what that looks like. I have a feeling this is just going to be yellow on nothing. And the actual destination will probably come from here. Where's our resizer for this one? That's this. Okay. So this, I think, will go into the destination of the composite mask. That yellow, let's find out. And let's go back to our regular just sort of RGB. Yeah, because we want to put the dancer on top of it. So one thing we need to do is switch this frame load cap to an input and then plug that input into our frame count so that everything is all the same. All right, so it should load 90 frames from the beginning into the thingy and then 90 frames out of this and slam it all together into here. Let's see what we get. Hey, I'm kind of proud of myself. All right, cool. So we actually have everything we need now. We need one more IPAdapter stack. And I bet you can guess why. We need the dancer too, our subject. RGB, yellow. Okay, so how do we get yellow? Well, yellow is red and green with no blue. Okay, and we're getting all this from, we're no longer getting it from we're no longer getting these from this. We're getting it from this, okay? So we're actually getting it from here. So we're going to plug these into the color to masks. Right? Yep, color to mask. Boop. So this should be able to put me or Tom Hanks. Maybe we'll make Tom Hanks dance here. So if I'm right, model. If I'm right, which I very rarely am, RGB yellow. Oh, is it running one right now? LOL. Cancel that. Cancel that. Boom, 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 boom. Looking good so far. Should be just person in the last one. Oh, we did it. We did it. Okay, so that's an animated background mask with a person on top, and the person is not being disrupted by the mask, which is super cool. So let's see what it does when we run it. And we'll call this Mask Assembly. Well, this got pretty dorky pretty quick. So what I think is going to happen now is a lot of nonsense because we haven't added ControlNet to this yet. But it should be a cool nonsense. After this nonsense is finished, we'll add ControlNet, and hopefully that'll bridge the gap and give us the depth that we need to make it not have disembodied Tom Hanks floating around the scene. But yeah, we've extracted all this information from these two masks. You can see why people have been doing masking in the compositing world for decades and decades and decades and decades. Because all this stuff that we're doing here is not only useful in AI, but like you can use this stuff in After Effects and Resolve and Premiere and all this other stuff to understand how to layer videos on top of each other. This is the simple process of cutting things out, and so like if you have these masks, right, you can put the original footage where the mask was, or the original footage where the mask wasn't, you know, and then switch between them, stuff like that. It's really going to help your post game to understand masking and its like capabilities. Because when you combine masking with different image blending modes, it's crazy. I know I'm preaching to the choir for a lot of you. I'm telling everybody, but for some people, you don't know what masks are, and these are masks. They're sick, they're helpful, they're useful. This should be absolute nonsense, and I'm here for it. Oh yeah. So right now, it just knows that Tom Hanks should be where Tom Hanks is in the mask, where the yellow bit is, where the dancer is. So this is kind of great. We want to actually make the dancer dance in the area. We're going to have to add ControlNet. So let's add that very soon. Okay. Apply ControlNet Advanced. We're going to add depth. We're going to add two control nets. We're going to add depth and we're going to add open pose. Okay. We're going to pass the conditioning through because that's where ControlNet lives, on the conditioning. So we're going from positive and negative out of the efficient loader through ControlNet into the K sampler. Okay. We've loaded our ControlNet loaders. For AnimateDiff, you need to use the advanced ControlNet loaders. And for the image, we're actually going to load a preprocessor. For the depth net, we're going to use depth anything. All right. And for the DWPose, we're going to use DWPose estimator. Okay. We need the resized version of the dance video, which is this node right here. Plug that into here and here. So that's going into our two preprocessors. And then we can plug the preprocessors into our ControlNet. And if we want to see what these do, same deal here. Grab one of these preview windows. Drop it down below. Same deal here. And just plug in these preprocessors into the video combines so you can see what they're doing. And again, turn these save outputs off. I shouldn't have had that on. We don't need to save the preview outputs for anything. You can save them if you want, but you really don't need to. Waste your hard drive space. Okay. Depth, I'm actually going to run at about 0.5, 0.5. Start. Oh no, we'll run it full, see what happens. Let's just YOLO the hell out of it. Okay. So what this will do now is it'll do the same run, except it's going to do a depth map estimation, and then it's going to do an open pose estimation. Then it's going to use that data to try to fit all the stuff into where it's supposed to be in the scene. You'll see what I mean as these pop up. So right now we're generating depth maps for all the frames. And now we're generating our open pose data, which is our little rainbow skeleton. And between the depth map and the rainbow skeleton, the AI can figure out where the person is supposed to be in the image, in each frame of the animation. There we go. Something's wrong. Oh. One thing I've noticed with ControlNet is adding ControlNet and like changing things in ControlNet doesn't register as a change in Comfy. So if you have a fixed seed, you actually need to change the seed for it to do anything when you run it. So now that I've changed the seed, it's going to do a new run and actually pay attention to the ControlNet changes that I made. It's just something to keep in mind. Another thing you can do is multiply in the colors for each mask so you can visualize, you know, the red, green, blue, and yellow. That's not hard to do at all. You just duplicate what I did up here with the blank and the blend in each of these. This is interesting. I don't see the dancer at all. I don't know what's happening. This is cool. I wonder if it's because of Deep Shrink and ControlNet. I have heard that there is an issue there. But let's run it, see what it do. Can you explain that Zora site you have some of your projects on? Is it an NFT store? Yeah, Zora is a NFT marketplace on Ethereum. They're cool. I've been on there for a while. Extremely low gas for Ethereum because it's all based on layer 2 stuff, especially the Zora stuff, like $3 or something to mint a piece, which is like nothing. And the cool thing is when someone mints one of your free pieces, you get half of the gas money. So you get like $1.50 for every mint. So, or whatever it works out to. Yeah, so if you have a free object on there, it does well, that's a decent chunk of change. But you can also put stuff up for the regular prices and stuff. It's just a regular NFT aggregator type place, but it incorporates a lot of the newer chains. Layer 2 stuff that's a lot cheaper to deal with on ETH than like working on ETH directly. The other thing I like about Zora is they also have like a creation system on their website, so you can like use AI tools and like a Canva style interface to like make your own stuff and mint it right there on the site. So that's kind of fun. I don't work there or anything though. There's the dancer. I feel like it's gonna have trouble understanding because like the background is moving and the dancer's dancing, but might be super interesting. Oh dear God. This is great for the weirdness factor, but it's not doing at all what I thought it would. Which is strange because he's totally cut out of the other ones. That's funny. Well, sometimes the experiments fail, friends. So what happens if we, instead of having a video, we just use like an image for the background? And then in this case, I want to add a, what do you call it? Image repeat batch, image batch. Yeah. And that goes in here. And you are what? As long as this run is, which is frame count. Change input to input and frame count into there. Okay, now I can plug in either the video mask or the static mask. So this should do a static mask the same length. Okay, we'll see what this does. Yes, I think that's the real move, Eugen, is to separate them and then use the mask to put the dancer in. Absolutely. We're just really messing with plugging stuff in wrong today. Oh, oh, it's still going. Oh, well, let's let that one cook a little bit. Okay. Oh, wait, did I? Yeah, it is doing it. It's just not doing it. So, which is weird because it is actually IP adaptering out a hole for the mask, you know, like it's odd. I wonder if we can render these normally and inpaint the mask in on top. I love it, just like his face just appears on the belly. This looks like nightmare fuel. Yeah, same thing. Wait a minute. Or latent image. Oh no, yeah, that's right. Well, screw that. All right. What if we encode the original dancer in and inpaint it? I don't remember how to do this. Let's go. I could have sworn. Yeah. What does this do? We're gonna go way down here. 320 by 576. We're gonna turn off the deep shrink, and we're just gonna see what this does. I don't know if I need this. I think this is for inpaint ControlNet. I feel like it's gonna crash when it hits the K sampler because like there's no way this is the right res and stuff. It's doing something. What? It's doing everything but the dancer. Trippy. Oh, this is trippy. This is cool. I don't know what it's gonna do, but it's cool. I feel like it's gonna be like an animation inside, but the background will be normal. Oh, okay. So yeah, we're literally just painting it over the original video and keeping that. That's pretty sweet. So how would I generate the background and then paint this on top? Or would I even need to? Questions. Sick. Definitely Tom Hankston. So then I would need this on top of the other one. So we would just do them separately. How did it understand to do this here and ignore the background? Because that's just the stuff that's in the mask. It's got to be a way to combine this. Do I just use the inpainting ControlNet then? What does the background look like with the dancer removed? Huh. Questions. So. I need that on my regular background. And I don't want to do it in post. I want to do it all in one run. There is an inpainting ControlNet, right? Yeah, inpaint. This goes here, I think. Video combined. Let's just see what this spits out, actually. Before. So can I inpaint preprocess both ways if I invert the mask? Yeah, because I don't want background. Okay, don't need you. Don't need you. You're in paint. In paint. All right. I'll turn you off. Turn you off. So we're gonna use this, but we're actually gonna use we don't need this now. Right? I think. You're not even hooked up. Okay. No. Right. We're learning things. I don't know what the hell this is doing. Might have to invert this mask. Because I think it's fucked. For lack of a more technical term. I think that's more like it. Because I really just wanted to dream over this and then do the background. Wait. Did I pull these from wrong place? Yes, I did. I need it from the upscale. You go here. Okay. We're putting him in the background. Yeah, I think it really does need to be two different runs. And you just mash them together in post. This is cool though. I think it should just render him. Oh, now that's interesting. Will the stuff move around him if his mask is cut out of the background? Huh. It's cool. It kind of dreams him in a bit in a creepy way. It's just the inpainting. Well, that's cool. So what if I put the control net back in then? What does that do? I think that just fixed the aspect. What else? How can I get something on him? It's interesting. Then if I reverse the mask, it'll just do him and leave the background alone. Yeah, I think you just have to do a mask and then do it in post. Cool to have the frames lined up, though. I guess you could do the run twice. Swap between them. Yeah, that's the same. Okay. Interesting. I bet you could do the morphing background with the person on it now, and it would be cool too. That would be that. I think. So if we do that, I'm curious how the inpainted dancer interacts with the background as it's moving. I like how it looks like he's like in the water, like his shoes are like in the water. I definitely need to play with inpainting ControlNet more. Because if you had like a scene, right, you could just mask out the center and like not like a static camera view of like flowers in the wind or something. You could cut a rectangle out of the center. Yeah, just mask it out easily using this workflow. Oh, that's interesting. It's totally broken now. Ooh, it fights with inpainting in depth a lot. That's really neat. It's really glitchy. Like the holodeck is broken or something. Kind of like that. Sure, that's a combination of control nets. Right on. Okay, one thing I want to cover before we go too down the rabbit hole with dancers and stuff. Just gonna get rid of all this stuff for the masking of the dancer. We're just gonna go back to literal single images. Probably don't need all these. All right. Mask, 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 and we'll get rid of this one. Okay, here's something really cool you can do now. Just trying to figure what I need. All right, we're going to copy these again. Skadoosh. All right, cool. So now we got 6. They won't be animated, so don't sweat the animations. In fact, I don't even think we need to repeat the batch anymore because it's just an image. Just needs to be resized. Upscale image. Oop. Add 8. Rename or change them to width and height to inputs. Grab them from here. Okay. Crop center. Put width and height back where they belong. All right, cool. Resizing, going into the masks. Masks are pulling their colors. Okay, we are going to do a 6 color mask. I've already made it, but it's the same thing I was doing in Blender. It's just 6. Okay, 255, 255, 255. We're just going to make all the colors. 2550, 255. So all red, all blue. And all green, all blue. Okay. 255, 2550, 250, 255, 0, 255, 255. As long as 2 in each for our next set of colors. And then we'll do 3 more images. I just need like all right, just grab 6 images of the Grand Canyon, pop them in there. So this is going to go and crop this and then cut these into little tiny masks. And then we're going to make a tall animation out of all these masks. But they're static, so it should just be nice and chill. It's another way to just like add composition to your image. Oh, no. I forgot to do a few things. They all need clip vision and IPAdapters. Okay. And then we need everything's connected. I think we need to send them plug in from here. Yeah. Okay. Nope, I forgot something else. Ah, right, because we unplugged ControlNet, so I got to plug the positive and negative back in here. Okay. Oh, something else is missing. Ah, we have to pass the models through. Model, 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 model. Okay, Yeah, see? So now we got this top strip, middle, second, third, fourth, fifth, sixth. So 6 strips with this one image because it's just, 6 colors. So what you should do is make a striped image with 6 different contexts all the way up from the top to the bottom. So you can imagine how this can be extrapolated, right? Because you can make masks in anything, MS Paint, whatever. Just use the primary colors and then extract the primary colors into masks. And then you can dream over the lines of those masks. You can also blur the edges of the masks too, and that'll like blur the two contexts together a little bit. So yeah, if you had a blur on the mask on the way in, colors might bleed into each other, and then you'll get like a little bit extra on each side, which will mix the two contexts together. Holy cow, 3 hours. You've been at this for a while. So we didn't get very defined lines here, and it's because I think it's because they're all of a very similar context, right? So I wonder if I can then where's the I wonder if yeah, let's try this. I'm gonna try putting something of each color. See if we can visualize what's going on here. I'm going to go shorter, 24 frames, and I'm going to go bigger, 512 by 896. And I'm also going to turn the deep shrink back on. And we're going to try this. There we go. Definitely getting some stuff going on. Red, green, blue, yellow, magenta, cyan. So yeah. Sky's the limit with this stuff. Go nuts. I think VRAM really is the limit, but it's pretty cool to be able to stack these contexts like this. You could do diagonally. You could do circles, squares, rectangles, triangles. Go nuts. Make some cool stuff. It's pretty awesome. I mean, that's literally what I asked for. So yeah, I think I'm going to leave it there. We've done subject masking. We've done RGB IPAdapter stuff. Done tiled IPAdapter stuff. We've done compositional masking for animations, Kohya Deep Shrink for higher scale resolution animations using AnimateLCM. Yeah, we covered a lot today. Yeah, if you want to go deeper into context smashing, animated LCM or animated IPAdapters masks or subject masking in general, both those workflows and the videos are available in the description below. Go ahead and grab them off the Discord and have fun. They're on my Discord. They're on Banadoko. They're everywhere. If you'd like what we do here, hit up the Patreon. Yeah, I'm working on some rewards for our supporters, but for now, you get access to special channel on Discord, and you get to hang out with us. And you know, Discord's free. You don't have to be a subscriber to hang out and get the workflows and stuff. It's really there just you know, if you support what we do and you wanna help me out. When I figure out some stuff that'll make life more convenient for you guys, assets and things like that, I will be putting it into like the supporters section of the Patreon, but just for now, I just don't know what I can provide other than workflows, and I don't want to put the workflows behind a paywall. So as soon as I figure out stuff like assets and things that you guys can use, I'll absolutely make them, and we'll make some packs, and it'll be fun. So look forward to that, and if you have suggestions, hit up the Discord. Let me know what you guys need, and I can make it. You need masks, you need mask packs. I don't know, special stuff, whatever I can do. Let me know. But yeah, enjoy the stuff and play with it and tag me in the stuff you make. I want to see it. Come by the Discord and yeah, smash that like button and all that stuff. Have a great night, everybody. Thank you. Thanks for hanging out for 3 hours while we choke through these workflows. I know it's a little dense, it's a little crazy, a little annoying, but you know, the more we do it, the easier it gets, the easier it is to understand, and the less scary it looks. So, yeah, keep at it. Thanks for hanging out, everybody.